Okay, so guys, yes, so let me start today's class by telling you CDP. CDP is Cisco Discovery Protocol. Cisco Discovery Protocol. Oops. Cisco Discovery Protocol, CDP. Okay, so now it is used to discover the Cisco devices. It is used to discover the Cisco devices. It's a layer 2 protocol. Suppose we have some like devices like this. Okay, this was a previous topology taken for some other students and all. Okay, so now if you check this one, so this switch is connected to the router here. Okay, so if I go to the switch or if I go to the router, then I execute the command show CDP neighbors. The command is show CDP neighbors. You can see the device is connected. So show CDP neighbors has listed say one router, BGL router something, and you can see it is connected to the local interface FA0/3 of the switch, and it is connected to, so this link is connected to the routers gig 0/0/0, and you can see which platform it is. It is the router is of ISR 4300 series router. Clear? Okay, now the next one, show CDP neighbors detail, will tell the detailed description of the device. So here you can see, so here the device ID is BGL router or the host name is BGL router. Then it is configured with an IP 10.1.0.1. Now if the platform is Cisco ISR 4300 series, it's a router. Now the interface connected to the local switch is fastnet 0/3, and the outgoing port means the interface connected to the router is gig 0/0/0, and it shows the version of iOS. It shows the version of iOS and whether it's working in half duplex or full duplex. Clear? So this is the CDP. Just yeah.
Just
Layer 2 protocol. Okay. Now, so this is the CDP, Cisco Discovery Protocol, used to find out the Cisco devices, connected Cisco devices. Okay. Now the next protocol is called LLDP, Link Layer Discovery Protocol. Link Layer Discovery Protocol. Link Layer Discovery Protocol, LLDP. LLDP. Okay, it's developed by IEEE to view the connected devices. So previously it was Cisco proprietary. Now this is IEEE used for the same purpose, to find out the connected network devices. Okay, so first thing is that you need to turn on the LLDP in the device, Cisco device. So by default LLDP will be disabled in this one. Okay, so you need to enable, so the command to enable is, you will go to the config mode and you will execute the command LLDP run. The command is LLDP run. Okay, so in the other device also you need to execute this command. We'll go to this router and we'll enable the LLDP.
So what's the shortcut to undo that domain?
You can give Ctrl+Shift+6, okay, and then release and press X. Or to disable this, you can go to the config mode and type no IP domain -lookup. Okay, if you execute this command, it will not work. Okay, now guys, now let me tell you. So here also we'll execute LLDP run. Okay, now if you check, so if you go to this switch and check, so the same command, this command is, so instead of CDP neighbors we'll execute the command show LLDP neighbors. Show LLDP neighbors. You can see one router is connected to its FA0/3. Okay, so now again you got one more command, show LLDP neighbors detail. Show LLDP neighbors detail is the command to view the detailed thing. So here you can see the detailed thing. So chassis ID, you can see the port ID, you can see the port description, whatever, the iOS thing, the version of iOS, like that you can see many things. Okay, so this is LLDP. Clear? Okay, now the next one, So LDP, CDP, now NTP. NTP is network time protocol. Network time protocol. Okay. So suppose that you take two devices now. Okay. Suppose that you take two routers. So network time protocol, or NTP, is used to synchronize the time between the network devices. Right. You need to have the time synchronized between the same, say that between the network devices, so that everyone will have the same time. Okay. So now let me connect it. Okay. Now suppose that here I am assigning an IP 10.0.0.1 and here I am assigning an IP 10.0.0.2. Suppose, so let me just configure this. Okay. Suppose okay, let the host name be server. Okay, so we got, when you configure the NTP, you will have an NTP server and client. Okay, so this is the NTP server. Okay, now let me give an IP. I say interface gig 0/0/0, IP address let it be 10.0.0.1. Okay, 10.0.0.1. Now let me give the other router IP 10.0.0.2 and the host name let it be NTP client. So host name NTP client. Okay, and now let me just give interface gig 0/0/1, IP address is 10.0.0.2 255.255.255.0 and let me give no shut. Okay, now we have given the IP address and made it up. Now we'll configure the NTP. So to configure the NTP, I told you this is the server. Okay, this is the server and this is the NTP client. So what we'll do is that we'll configure the NTP, we'll configure the time in the server. Okay, so now let me configure the time in the server. So now if you check show clock, so now it's showing some 1993 values. So now let me configure the clock here. The command is clock set. Then you are going to give the time. Suppose it is 17. This is 5:51. So 17. So 52. 00. Today's date is 6th April. Right. 6th April 2020. Okay. You set the clock, and if you view the clock now, you can see the time. Okay. Now you're gonna set this as the NTP server. So you got only a simple command, a single simple command. The command is NTP master. NTP master. Then we will give a number. Okay, this number is called startup number. So which defines how much trustworthy this time is. So 1, 2, 3, 4 like that. Say if it goes, then say going down the, say if you have the greater than number, so it means that lesser trustworthy. Getting it? Okay. Now, so NTP master 1. So this router will act as NTP server. Okay. Now, if you check the NTP client here, if you check the NTP client, do show clock. So here you have the time 1993. Now I am setting this as the NTP client. To set this as the NTP client, you will define the NTP server's IP. You will define the NTP server's IP. So the command is NTP server. NTP server, then we'll give the server's IP, which is 10.0.0.1. Clear? Now, if you check, so show clock, it's still 1993. So it will take some time to get synchronized with the server. Okay, so let me fast forward the time now. Okay, now that I fast forwarded the time, so now when you check, so previously the time is 1993. Now if you check, you can see the time now has become April 6, 2022 because it has synchronized the time with the time of the server. Getting it? So the network devices will have the same time. Getting it? Okay. Now you got one more command, show. The show command, show NTP associations. Show NTP association. So this will tell you, so this is the time here. Okay, or say the address to which it has synchronized is 10.0.0.1. okay, yes. And you got one more command, show NTP status. Okay, you can see the clock is synchronized and the reference clock is 10.0.0.1. It's the reference clock. Any doubts? Okay, this is the NTP. Simple portions, right? Okay, so this is the NTP topic. Now we do not have the configurations. Now we'll have only theory portion. Okay, AAA Snmp Syslog. Okay, so first let me tell you what is AAA. So AAA means AAA authentication, authorization, accounting. It's called authentication, authorization, accounting. Authentication, authorization, accounting. It is responsible for all the three things. So authentication, let me tell you what it is. Authentication means, okay, authentication, authorization, accounting. Okay, now authentication means authenticating the user, or if at all you are trying to log into the router, say it says whether you are say authenticated, I mean whether you have the password, the correct username and password. So it will check for the, if at all you are logging to the Facebook, right? So they will ask for the username and password. If you provide, then the authentication will be successful. Clear? Yes, Sajin, what happened? Okay, yes. So now, even though you say okay, you seem to look at his notebook. What happened? Okay, now, so that's the authentication. Now authorization means how much authority you have to execute certain commands. Okay, suppose that you are not authorized. Suppose I am the only authorized person to say shut off the AC. Okay, then I'll be like turning off the AC. So that means you do not have the authority. So again, you will have, when you are working as a junior network admin, you may not have certain authority. So if at all you are in the privileged execution mode, if at all you do not have sufficient authority, you will not be able to type even the configure terminal. Getting it? The command will not work unless and until you have that authority to execute the commands. Clear? So again, so setting the username and password, you can set the authority. You will have various levels of authority. Okay, you can set the authority. Now accounting means, so it will keep track of what all things you do it. Suppose that I am the senior network admin and I change the password. So it will be there in the accounting. In this so and so time, I have changed that so and so password. Clear? So that is accounting. So authentication, authorization and accounting. Okay, so in the production environment, you will have such a device, AAA device. Okay, so AAA server will be there. AAA server will be there. So here, let me tell you. So if you have a switch and if you have a router, say suppose if you have switches and routers and all, when you try to log into the router, they will ask you for the console password, right, or the VTY password. So if they ask you the console and the VTY password, you might have configured something login local. So login local means, say we have configured the local username and password. But if you have the AAA, you will mention something else. Okay, so the command, let me just show it to you here. Okay, so line VTY 015 login, instead of local we will mention the authentication. Authenticate using AAA method list. Okay, so what happens is that, say here, along with this, say suppose you got routers, multiple routers here. Okay, so you are trying to access these routers. Okay, and you will have a AAA server. You will have a AAA server. So what you're going to do is that, say you will be configuring. Okay. Yes. So you will be configuring the AAA in such a way that, so all the device, I mean you will be configuring all the device in such a way that if at all you try to log in through the VTY, or if at all you try to log into the console, they'll ask the AAA server, hey AAA server, say so and so username with so and so password is trying to log in, whether you have such a username and password. So the AAA server will check, will authenticate So they'll check whether such a username exists and such a password is correct or not. If at all it is correct, then they'll be telling yes, such a username exists and the password is right, allow him to log into the device. Clear? Okay, so that's the AAA. Okay, now, and the next thing. So here, the next thing is that, where is it? So now, AAA, if you want to execute the AAA, you got two services. You got two services. The first is called, or two protocols you can say, the first is called Radius. First is called Radius and the next one is called TACAX. TACAX. Okay, so Radius and TACAX. So you can execute AAA with two, say, services or two protocols, Radius and TACAX. Clear? So the rest of the things you will study it in CCNP. I mean the security level. Okay, so security level you will be studying much more deeper things. This is just an overview. Okay, now let me tell you. Yes. Then you got something called Snmp. You got something called Snmp. Simple Network Management Protocol. Simple Network Management Protocol. Okay, so let me tell you Simple Network Management Protocol. So SNMP, sorry. So in SNMP, what happens is that, so here you use this SNMP to manage the network, or to manage the network components, or to manage the network devices. So suppose you have router 1, router 2, router 3, etc. So have you ever thought of managing the routers? So the routers, you might have heard of it, okay, or you might have at least seen about it. So if at all you might have went to, say, now that you have towers, right? You have the towers. Okay, you might have went to like the tower, right? Say the Airtel tower, or suppose the Vodafone tower or Jio tower, whatever it is. So the tower, so after that you will have, from the tower you will have some connections going to a room or a box. You might have seen a big box. So, or you can see a metal box there. You can get into that metal box and you will find racks of devices. You will find racks of devices. Okay, and when you go inside, it will be fully air conditioned. Okay, it is not for us really, it is for those machines, those devices that we are keeping the air conditioning. So the routers will be turned on for years, maybe. Okay, for years and all, it might be turned on. So for that, so it should be working or it will be working 24/7, right, for years. So it shouldn't go bad, or there shouldn't be any heat issue, or there shouldn't be any problems related to that, right? So for that we will be having ACs or air conditioning system inside that network room and all. Okay, so now coming to here, because so here, why did I tell you, means that here we are taking care of the network devices. So now taking care of the network devices, and we'll be monitoring those things. So suppose we got routers, all these routers will be like put in, say, will be in the network room, and it will be air conditioned, and we'll be monitoring those temperature, the like power supply, those things related to the routers and switches. Okay, for all the network devices, we'll keep on monitoring their health. Okay, using a protocol called SNMP. Using the protocol called SNMP. So here we got an SNMP agent. This is an SNMP agent. In each router you got an agent here. You got an agent. And here in a computer or in a server you will have, you will install a software which is called SNMP Manager. SNMP agent and SNMP Manager. And what you're going to do is you're going to say this manager is going to send some messages to the agent. Okay, they are going to send some messages to the agent. So you can, or the manager can send set or get message. The manager can send set or get message. Get message is to get the values from the device. Okay, so SNMP agent will be having something called MIB, Management Information Base, which will be having lot of values. Okay, so get those values, get the temperature values, get the fan power supply values, get the fan values, like that. Okay, now set means you can set certain values there. If at all the temperature goes about 22 degrees Celsius, or if at all the temperature goes around, say about 23 degrees Celsius, just inform me, or set that value. You are setting a threshold value, so setting the threshold value, getting it? Now, so this router will send certain messages there. So it's called inform message or trap message, trap or inform message. So trap, it's UDP, and inform, say you have the reliability. Okay, so here trap or inform will be the messages sent back from the agent to the SNMP manager. Clear? Okay, so this is how you're gonna manage the, say, what do you say, the network devices using SNMP. And again, let me tell you, so what happens is that you will be managing with the help of a monitoring tool. You will have a monitoring tool. So you will have L1 engineers or L1 analyst. You will have analysts who will be using the monitoring tool. They will monitor everything. So they will use certain tools, monitoring tools. Suppose, say, you might have heard of it, like you may not, or you might have. Okay, say, I'm not getting it. So even I worked on it, but I forgot that. Okay, so there are certain monitoring tools, SolarWinds, something like that. Okay, they have. So monitoring tool and all, they have it. Okay, and they will be monitoring the condition of each network devices. If at all some and some error happens, it will sprang up in the monitoring tool. Clear? Okay. Now, and again, last thing, SNMP has got many versions. SNMP has got many versions. Say SNMP version 1, SNMP version 2, and version 2C. Okay, and SNMP version 3. These are the major versions: SNMP version 1, V2C, and V3. Okay, yes. Okay, now done. Sajin, done. Okay, now the next one. So in the textbook and all, I suppose they have given some commands, SNMP commands and all. You can go through that. We are not going to execute because we do not have. Say there also they haven't mentioned about this manager tool, how to install the managing tool, how to manage. They have not mentioned it. They have just mentioned some commands which can be executed in the router. Okay, you only have a single router part there. We do not have any other, so you will be like running a software in this what do you say, in the server, which will act as the SNMP manager, and you can go with those things. Okay, now you got some more things called Syslog. It's called Syslog. Syslog. So Syslog are system log messages. System log messages. System log messages. Okay, so now for system log message, let me tell you. So you might have seen some messages like this. Here you can see. Okay, so if at all I make the interface up, interface say gig 0/0/0, I'm making it down, shut down. So you can see certain messages. Line protocol has gone down. So these are the syslog messages. Okay, this is just to mention us, or to mention the users what happens in the router. So by default you will get all these syslog messages in the console. Okay, you will get all these syslog messages in the console, and you can save all these messages to some other device called syslog server. You will have a syslog server to which you will store all the syslog messages. Okay, so there in syslog message you will have, say you got many messages, many types of message. So 0, 1, 2, 3, 4, 5, 6, 7, you got multiple messages, where 0 and 1 are the emergency and the alert. So these are the highest level, the highest, so the emergency and the critical, I suppose. Okay, so these are the highest levels of messages. If at all you didn't take care of these message, then the router itself may go down. Okay, now going with the 2, 3 and 4, I suppose these are less severe when compared to say the 0 and 1. Okay, now 5 and 6. So 5, I suppose it is notification or something. 6 is information. 5 is information and 6 is notification, something like that. So this one, if at all it goes down, you can see this is 5. The severity level is 5. Not that much important. Okay, you have made this manually down, so that is not so important here. Just to notify you that they are giving this message. Okay, getting it? Any doubts? Okay. Sorry. So this is the syslog, system log messages. Okay. Now the next thing. Okay. Now let me tell you the next. QoS tradition. So QoS, you can write the heading QoS. So guys, again it's theory portion, so if at all you need a break, let me know. Okay, I can give you break for multiple times because today we will be having only theory and only less topic is there. Okay, so today quality of service. Quality of service, QoS. Okay, so now QoS here. So by doing the QoS or quality of service, you can manage many network characteristic. Okay, suppose when you are sending some voice packets, when you are sending some voice or the real-time packets, now that I am taking the class in Zoom, it's an interactive session, right? So it is like the interactive or the voice plus video or the interactive sessions. You need to have maximum bandwidth. You need to have maximum bandwidth. Minimum delay. Minimum delay means if at all I have sent it, it needs to be sent ASAP without any delay. Okay, without any time period. Now next, minimum loss. Minimum loss. Suppose if I am sending 100 packets, say it should be like with minimum loss means say of the 100 packets, okay, maybe like 95 or 96 packets need to receive, okay, at the destination. So if at all you are like losing, or if at all only 50 packets are received, then you can consider it as higher loss. Okay, so it should have minimum loss and minimum jitter. Minimum jitter, J-I-T-T-E-R. Let me tell you what it is. If at all I am sending something from source to destination, if I am sending something for the first time, it is taking 1 microsecond or it is taking 1 millisecond. 1 millisecond to reach the destination. Suppose if I am sending something for the second time, again if it is taking 1 millisecond, that means you do not have any time delay there. You only have, or so the time delay or the say delay is every time it is 1 millisecond. You do not have any variation in the delay. Okay, now if at all you are sending, say again the next one, it is going 1 millisecond. So this is considered to be one of say the best communication because you do not have any variation in the delay. Okay, now so the variation in the delay is called jitter. The variation in the delay is called jitter. So the variation, so now the jitter is 0. For better communication, the jitter must be 0 or the jitter should be minimum. Clear? Okay, so these are the network characteristics. So with QoS you can say for a voice or some for video packets or whatever the interactive sessions, you can assign maximum bandwidth, minimum delay, minimum loss, minimum jitter. If it's a batch application, meaning if at all you are browsing the internet, maybe the casual HTTP packets or some others, the usual packets, then you can go with say the maximum, the bandwidth. It's okay to have a lesser bandwidth. It is okay to have some more delay. It is okay to have some more loss, or it is okay to have some more jitter. Clear? Okay. So these with the, these network characteristics can be configured. Okay. Now in QoS, what we are going to do is, so we got Qos tools here. You got different Qos tools. So what happens is that, so this Qos means how do you manage the packets that you receive in the router. So when you receive the packets in the router, router. The first thing that they're going to do is they're going to mark and classify it. They'll do the marking first. They'll do the marking. How much important it is. How much important it is. So if it is marked with certain values, then they will consider it as highly important. Okay, so that's the marking. But usually the marking is not done in the routers. It can be done in the switch also. Okay, so the marking is done in IP header. The marking is done in IP header. Okay, in the IP header, let me tell you. So marking is done in the IP header in a section called TOS, type of service field. It's done in type of service field. In the type of service field, you got 8 bits. You got 8 bits, of which 6 bits here are called DSCP, differentiated service code point, or DSCP. Okay, differentiated service code point, DSCP bits. So 6 bits will be like this: 0, 0, 0, 0, 0, 0. The first 3 bits, it says the priority, and the second 3 bits, it says the delay. Okay, or you can say the drop precedence. This is the drop precedence. Okay, so now, so here you got 3 bits here. So the values can be from 0 to 7. So the first value is called, so if you have the value 0, it's called best effort delivery. Okay, BE. If the value is 1, then that is called 1 to 4. 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. These values are called assured forward, AF, or assured forwarding. Then you got another value 101. It is called EF, expedited forwarding. It's called expedited forward. So just to understand, that's it. Now the next one is called, say, 110111. This is called inter-network control, and this is called network control. These two traffic are considered as the highest priority traffic. The highest priority traffic, and it is used for the working of the routers and switches. It is used for the working of routers and switches. Now expedited forward is considered to be the it is considered to be the most premium packet with respect to the user defined packet. So whatever that we send from our computer is defined as the user defined packet. Whenever you are browsing the internet, or whenever you are downloading something, or whenever you do something in the, say, in the computer or the internet network, you are sending some packets. So expedited forward is reserved for the interactive sessions. It is reserved for the interactive or the live voice or such things. Okay, so that is considered as the most premium packet, or it is considered as the highest level of, say, priority among user defined packets. Now AF, again, lesser priority. Okay, so this one is much more lesser priority. AF, this is 4, the value is 4. This value is 3, this value is 2, this value is 1. So EF also got the value here, it is 5. So considering AF3, suppose this precedence is 3-1, and considering AF 4-2 or 4-1, so where 3 and 4 defines this value. So considering this one, AF4 will be having much more priority than AF3. Getting it? Okay, so nothing. Okay, just you got to understand certain values: 0, 1, 2, 3, 4, 5, 6, 7, of which the highest will be this one, IC and NC, which is having 5, 6 and 7 values respectively. Okay, 6 and 7. Okay, so now if at all, say, suppose NC suppose 7 some value is there, and suppose EF 5-1. So NC will be considered as the most, yes, prioritized packet. With respect to, so if at all you want to configure the network, I mean not the network related things, but say if you want to like go with the packets, the user defined packets, EF will be having the highest one, where EF will have the number starting with 5, EF 5-1, then it will be considered with the highest priority. So with respect to EF 5-1 and AF 4-1, EF will be having the highest priority. Okay, then comes EF 4-1, then comes AF 4-1, then comes AF 3-1, like that. Clear? Okay. Now, so this is how you will do the marking in the IP packet. Now the next thing, So the marking can also be done in switches. The marking can also be done in the switches when it is sent through the trunking, when it is sent through the trunk links. When it is sent through the trunk links, I have told you that you can go with two encapsulation methods. One is called ISL and the other is called .1q. When you are using the .1q, I have told you that to the frame they will be adding a 4 bytes tag. They will be adding a 4 bytes tag. Anish? Okay, here. Okay, in the 4 bytes tag, you got a 3-bit value which is called class of service field, where you will do the marking. Clear? So this is where you will do the marking. Okay, now don't want to go into in depth of these things now. Okay, I know that you are getting bored. Okay, so now first is, say, the Qos tools that we discussed is, first is the marking, and the second one is called classify. Classify. When some packets are received in the router, you will classify the packets. You will classify the packets. So suppose you will classify, the router will classify it as voice packet, then video packet, then the batch application packet. They will classify it like this. Okay, so that's the classifying. And the next thing that they will do is that queuing. 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 Okay, so queuing means you are putting the queues. You are receiving 1000 packets now. The router is receiving 1000 packets. So first they'll say like classify it and they will put into the queues. So queuing means in this video queue you will have multiple video packets now. Multiple video packets getting ready to send over to the network. Okay, now again you will have voice. So what you will do is that voice, okay, you will queue it, and the batch application also you will queue it. So that's the process of queuing. Okay, now the next one is called scheduling. Fourth one is called scheduling. Scheduling. Now that these packets are queued, you have the queue here. Now suppose you are sending via FastInternet 0/0. So FastInternet 0/0 will be able to send 100 megabits per second. Suppose each packet, so usually we'll tell the size with respect to bytes. Now that consider for easy purpose, I am just telling with respect to bits. Each packet is of or consists of size 1 megabit. Then in 1 second you will only be able to send 100 packets, because each packet has a size of 1 megabit, and in a second you can only send 100 megabits of data. So that means you are only able to send 100 packets per second. Okay, so in that case, so if at all you are able to send only 100 packets per second, you need to schedule how many packets in a second, how many video packets should be sent in that second, how many voice packets should be sent, how many batch application packets should be sent. Getting it? So suppose 40 video packets can be sent. Now 30 voice application can be, or the voice packets can be sent, and the 30 batch application packets can be sent. So in a second, 40 video packets, 40 voice packet, and 30, say now 40 plus 30, 70, 70 plus 30, 100. So in that second, so this is how they'll send the, or they'll schedule it. Getting it? Okay, so scheduler. Okay, have you heard of round robin scheduling and all? Okay, so that's a kind of scheduler. Okay, so again, first in first out, the queuing. Okay, you might have heard of first in first out, first in last out. So you have heard of many things there. Okay, not gonna go into that because again it will go into theory thing. Okay, now so this is the value. The fourth value is scheduling. Now the fifth tool, that's called policy. Okay, let me tell you what it is. Okay, you can say here, suppose you have taken a connection, service provider connection. You have taken a service provider connection. So the service provider connection that you have taken is 100 Mbps. 100 Mbps, 100 megabits per second. Suppose in the first instant that you are sending 101 megabits per second. 1 MB is extra. 1 MB is extra. So what you're going to do? 1 MB is extra, right? So what the service provider will do is that you have only taken up to 100 Mbps data. Okay, so if at all you got, or if at all you are sending 101 Mbps, then they are going to chop off the data. They are going to chop off the data. Okay, so what happens? The loss, the data loss will happen to us. So to avoid policing, so the chopping of the data is called policing, and to avoid policing, we'll do shaping at our end. We'll do shaping at our end. Shaping means, in the first instance, suppose you are sending 101 megabits of data. Okay, so 1 MB is extra. 1 megabit is extra. And in the second instant, you are only sending 90 megabits of data. You are only sending 90 megabits. So the extra 1 MB can be sent at the second instant. Getting it? So it is delayed so that you will be sending it in the second instant. So in the second instant, you will be sending 91 megabits of data. Clear? So this is called shaping. You are shaping your traffic. Clear? So these are the QoS tools. Now, so that's the QoS part, quality of service. Okay. Now the next one. Okay. Again, if you need any break, I suppose you will tell me. Okay. Need? Okay. So then I'll give you a break. After that, we'll continue with these things. Okay. Yes. And by the way, so let me pause record. Okay. So now, guys, before going to traditional versus this SDN, let me go with GR, ProxyRp, and Icmp and Hsrp. Okay, GRP and all, there are chances that they'll ask in the interview. GR, ProxyRp and all, there are chances that they'll ask in the interview. QoS and all is never asked in the interview. Okay, so let me ask you, what is ARP? Address Resolution Protocol. Why is it used? To discover the MAC address using the IP address. So to find out the layer 2 address using layer 3 address. Clear? If at all you do not know the MAC address of a device and only you know the IP address, but again, if you want to send a data, you will have to get the MAC address or the discover the MAC address by sending ARP. ARP request will be sent. ARP request will be sent, and in return you will receive an ARP reply. Okay, so now, so I have taught you the ARP, and I still hope that you still have that knowledge with you. Okay, it's there, it's still in your mind, I suppose. That's very, 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 very important topic. That's a 200% sure that they will ask the ARP. Okay, in the interview. Now, so now let me tell you about GRP, the gracious ARP. It's called gracious ARP. Okay, so now let me take a PowerPoint. Just give me a moment. Yes. So here the gracious ARP. Okay. So now the gracious ARP is an ARP response that was not prompted by an ARP request. Okay. Suppose you got some machines, and the usual ARP or the usual procedure is that if at all one machine doesn't know the second machine's MAC address, he is going to send the ARP request, and the response for the response, or as a response, he will send the ARP reply. But gracious ARP doesn't need any ARP request. It doesn't need any ARP request. It's actually an ARP response or an ARP reply. Okay, so the reply, if at all, let me tell you an example. If at all a computer is added, a new computer is added, or if at all the computer is given an IP address, or if at all the IP is changed, then what he will send is that he will send a gracious ARP. He will send a gracious ARP. He will not wait for any ARP request to come, but instead he will send the ARP, the gracious ARP, which is an ARP reply. It's an ARP reply. So if at all the ARP reply or the gracious ARP is sent, then the advantage is that all the machine will come to know about this machine. or the machine will come to know about the newly connected machine. So and so IP is there with a so and so MAC address. Clear? Okay. And again, one more advantage is there. So let me tell you. So if at all you are given the IP 192.168.10.1. Okay. So when he sends the gracious ARP, let me tell you, if at all another machine is there, okay, so he will understand, okay, somebody has come with, say, this machine is having the same IP. Okay, then it will help us to find out the address duplication. Okay, so this machine will understand, okay, somebody has come with my IP. I already have this IP, so he shouldn't use this IP. So he'll reply back, hey, who are you to use my IP? I am already here with this IP, and say this just to inform that already an address is used. Clear? So Gsrp is used, or here you can read it. So gracious ARP is sent as a broadcast. It's sent as a broadcast, as a way for a node to announce or update its IP to MAC mapping to the entire network. Clear? Yes. Okay. Okay. Now, next you got a proxy ARP. You got proxy ARP. So to tell you what is proxy ARP, let me tell you. So here, suppose, let me tell you with an example. Here. Suppose we got, who is it? Ashwin. And we got Susmit. We got Sajin, and we got Deva. Okay. Now, so here Ashwin is in CCNA class. Susmit also is in CCNA class. Sajin is a part of CCNA as well as CCNP. Sajin is a part of CCNA and CCNP. Deva is a part of CCNP class. Okay. Now, Ashwin has got a book. Ashwin has got a notebook. Suppose he doesn't know who is Deva. He has got a notebook of Deva. Okay. Now, he will think that Deva is in CCNA class because he has got the notebook from the CCNA class or something. Okay. So suppose Ashwin is thinking that Deva is in CCNA class, but really Deva is in CCNP class. Okay. This is CCNP. And this is CCN. So what Ashwin will do? Ashwin will say, Ashwin doesn't know who is Deva. Okay, so Ashwin will tell like this, hey, or he will broadcast. So he will tell he will say, ask like this, hey Deva, who is Deva here? I have your notebook. So it will be sent as a broadcast, will be sent to Sajin, will be sent to Susmit also. Okay, and will be sent to Anish. Okay, and suppose say Vaman is there, it will be sent to Vaman also. Okay, so here it is a broadcast, it will be sent to everyone. Now, none of them will reply. So Sajin will not reply, Vaman will not reply, Anish will not reply, Susmit will not reply, because he has asked for Deva only, and Deva is not at all present in this class. So to reply back, Deva is not at all present in the class. So nobody will reply back. Okay. Now, Sajin is in CCNA and CCNP class. So Sajin knows that Ashwin is never gonna get a reply back. Okay. So what he will do is that Sajin will say, he'll tell some lies. He'll tell that, or he will say that I am Deva. Okay, so Ashwin will think that, okay, this is Deva, but really that is Sajin. So if there is a notebook, then Ashwin will pass it to Sajin, thinking that he has passed to the correct person, Deva. Okay, so what actually Sajin is doing, he is doing a proxy. Okay, he is having a false identity and he is acting as a proxy. Okay, and Sajin, he will then, so now that he has got the notebook, he will then forward it to Deva. Getting it? The similar thing happens in proxy ARP. The similar thing happens in proxy ARP. So here the computer C1. Okay, the computer C1 is misconfigured. Here you got two networks. This network is 192.168.10, sorry, yes, 1.0. 1.0/24 network. And this network is 192.168.50.0/24 network. So it is C1 is misconfigured with an IP. Say 192.168.1.11/16. Okay, so he thinks that 192.160.50.50 also belongs to the same network. Obviously, I suppose you have understood, because it's /16 and the assignable IP starts from 192.160.1.1 to 192.168.255.254. And obviously, this 50.50 will be coming in the same network. Okay, so if at all computer C1 wants to communicate to 192.160.50.50, what he will do, he will send out an ARP request. He'll send out an ARP request. So the ARP request will be sent. Okay, so the target IP will be 192.168.50.50. Okay, and the target MAC is nil. Clear? Now it will send as a broadcast, will be sent to all the nodes here, but none of them will reply. Okay, but R7 understands the same thing. He is never gonna get the reply back, because 192.168.50 is in another network. So if at all router R7 is configured with a proxy ARP, if it is configured with a proxy ARP, he will send out a proxy ARP reply, or he'll send out a ARP reply. So the ARP reply says, I am 192.168.50.50 with his own MAC address. Getting it? So really, he is not having such an IP, but he is just sending a proxy. Clear? Okay, so then C1 will think that, okay, this 192.168.50.50 is having this MAC address, and it will be filled in the, say, ARP cache table. Clear? Okay. Now if at all he wants to send something to 192.168.50.50, he will be sending the MAC address with this router's MAC address. Clear? And it will be received to the router. Router will forward the message to C3. So router is doing the proxy ARP here. Clear? Okay. Now let me tell you, by default all the Cisco routers are enabled with proxy ARP. By default all the Cisco routers are enabled with proxy ARP. So they will send the proxy ARP here, or the ARP reply. Clear? Okay. So this also they are gonna ask. There are chances that they'll ask the proxy ARP and gracious ARP. And 200% sure they'll ask the ARP. Okay.
How will be the packet flow?
Packet flow, let me tell you. So the packet flow is that, say the computer C1. So C1 at first what he is going to do is that send the ARP and all. Okay, so sending the ARP, I suppose you know it already. Okay, now that I'm gonna tell only the packet flow. So the source IP will be 192.168.1.1 and the destination IP will be 192.168.50.50. Now the source MAC will be the MAC address of C1 and the destination MAC will be the MAC address of this router. So it will be sent to switch 2. Switch 2 will already know that where this MAC address is sitting. It might be in F0/1. If it is there in the CAM table, then he is gonna forward it through F0/1. Okay, and the router will receive it and will say strip off this thing, what the this layer 2 header and trailer, and will check this packet. Okay, check this packet and he will understand. So 192.168.50.50 is connected via this F0/2 or F0/1. Then he'll be sending it via F0/1. At that time the packet will remain the same, but the source, so here they will again add a header, layer 2 header, where they'll have the source IP, source MAC as this MAC, and the destination MAC will be this MAC address. Clear? Okay. So this is what that happens. Okay. Now the next thing, the proxy RP we have discussed. Then one more thing. Okay. What happened? I don't know. Okay, whatever. So the ICMP protocol. ICMP or Internet Control Message Protocol. Now ICMP message, here you can see, you have already, so far we have been using the ICMP only, right? For ping, when we ping something, we are really using the ICMP protocol. Okay, so you checking the connectivity between machines, reporting errors, etc. So this is the header, this is the structure of ICMP package. You got a layer 2 header, and in between you have a layer 3 header, and then you got an ICMP header. This is the structure of ICMP header. This is the structure of ICMP header. So you have a type field, you have a code field, you got a checksum field, you got some variable fields also. Okay, so type 0 and code 0 says it's just the echo reply, that means the ping is successful. And type 3 code 0, it means network unreachable. Type 3 code 1 host unreachable. Type 3 code 2 protocol unreachable. Type 3 code 3 port unreachable. Type 8 echo request, you are sending something. Okay, and type 11 TTL exceeded, it's an error message, TTL exceeded. And type 30 is trace route. Okay, yes. No need to by heart these things, just understand. Say suppose echo reply and echo request, go with those two things. Okay, usually they are not going to ask you like this, okay, but you can understand this packet structure. Now, so this is, yeah,
What is the ICMP header?
ICMP header is this one. This is the ICMP header. Okay, and the contents I have just told you this. Got it? Sure. Okay. Now, so this is the ICMP. Now guys, now we'll go with the next one, which is it. So GR proxy ARP ICMP. Okay, now we'll go with FHRP. So you can write the heading FHRP. FHRP is First Hope Redundancy Protocol. So let me write it down. FHRP, First Hope Redundancy Protocol. First Hope Redundancy Protocol. Okay, so here FHRP, you got multiple protocols in that. So it's a family of protocols, and let me tell you why it is used. So if at all you have a set of devices here, you got a set of devices which is having the IP 10.002.3.4.5 and all. Okay, now which can be connected to a router. Yes, can be connected to a switch, then to a router. Okay, so let me draw it like this. So you got a switch and it is connected to router. Okay, now from this router, suppose this is the internet connection, and suppose this is the Airtel connection. So suppose you are having the internet connection like this. So this is the R1 and this is Airtel connection, and you are connected to the Google from here. You're connected to Google. Now suppose the service, the company or the organization will be having minimum 2 connections. If at all the Airtel goes down, you need to have one more connection, right, as a backup. So what you will do is that you will take one more connection, suppose R2, and consider that this is Geo connection or this is Vodafone connection, Vodafone or Geo, whatever it is. Okay, now suppose this router has been configured with an IP 10.00.100, 10.00.100, and this has been configured with an IP 10.00.101. Okay, now if at all, so suppose that Airtel is our primary connection, Airtel is the primary connection and Vodafone is our secondary connection. Okay, now if at all the primary connection is Airtel, what you're going to do is you're going to set in all the computers, you're going to set the gateway as 10.00.100. So all the packets will be forwarded through Airtel. Clear? Now if at all the Airtel goes down, then what will you do? Backup. For that you need to change the gateway address to 10.00.101. Okay, so it is okay to change the gateway to 101 for a single machine, but what if you have multiple machines? You have 100 machines. Then for each computer you need to go there and give the gateway as 101, right? So it's really a difficult thing. Okay, to avoid those things or to make it easy, we will configure Fhrp, first hop redundancy protocol, so that in case if the Airtel is down, say the traffic will be automatically redirected to the Vodafone. Clear? Now, so Fhrp, you got 3 protocols inside Fhrp. The first is called Hsrp, Hot Standby Redundancy Protocol. Hot Standby Redundancy Protocol. The second is VRRP, Virtual Router Redundancy Protocol. Virtual Router Redundancy Protocol. The third is Lldp, Gateway Load Balancing Protocol. So Hsrp, VRRP and Lldp, of which we will be just theoretically we will study Hsrp. Okay, just give me a minute. Okay, so we'll be studying Hsrp, Hot Standby Redundancy Protocol. So now done. Okay, so now suppose that you have implemented Hsrp. If you implement Hsrp here, say one router will act as a active router. One router will act as an active router. So suppose R1 is the active router. Okay, then the other router will act as a standby router. Standby. One will act as an active router and the other will act as a standby router. Okay, now both the routers are configured with a virtual IP. Both the routers are configured with a virtual IP. Virtual IP means an unused IP. Okay, so here we will configure the IP 10.00.200. Suppose it is not used by anyone. Okay, here also we will configure 10.00.200. Okay, now the gateway of all these machines will be set as 10.00.200. Clear? Now comes the thing. So now even if these routers are configured with an IP 10.00.200, only the active router will be using this IP. Only the active router will be using this IP. So suppose the active router is R1. So R1 will use 10.0.0.200. So all the packets will be forwarded to R1, and via the Airtel you will get the connection. Clear? Now, between the active router and the standby router, they will be sending certain packets. These packets are called hello packets. These packets are called hello packets. It's not the OSPF hello packet, it is Hsrp hello packet, different hello packet. It is to test between, say again, it is just to make sure that these routers are, say the one router has not failed. Okay, so what happens is that they will share hello packets, and the hello packets will be shared for each 3 seconds. They will share one hello packet. For every 3 seconds they will share one hello packet. So they keep sharing the hello packet. Okay, now if at all this link goes down, let me tell you. So this standby router R2 will wait for default of 10 seconds. He'll wait for 10 seconds, which is called hold down timer or something. Okay, so he'll wait for 10 seconds. If he didn't get a hello back, then this guy will become the active. This guy will become the active, and this guy will change its state to standby. And you know the specialty of the active router. The active router will start using the virtual IP 10.0.0.100. So if at all, if you have any packets to be sent to the internet or something, it will be sent to the R2 automatically. It will be sent to the R2 automatically. Clear? Yes. If it is one more router, okay, again, okay, this will be standby only. Okay, again you can, those things again you will study it in the NP level. Okay, you can study that in the NP level. Again, load balancing can be say established, those things you and all later you will study it in here. Okay, NP. So I suppose Hsrp can accommodate up to 4 routers or something. 4 routers, I don't remember how much it is. Okay, so now yes. Gateway, actually we don't need to change the gateway, it is kept constant. Okay, so 200 will not at all change it. The router will, so this router will start using the 200 at first. Later this router will start using it. Okay, then what you need is the ARP. What you need is the ARP. So ARP, so this guy will generate the gracious ARP. They'll generate the gracious ARP and all, which again you will study those things in the CCNP level. Okay, so for updating the MAC address and all, they'll use the ARP, which will be sent by the router, and it will be like broadcasted. So all the machines will receive the notification that okay, now 10.0.0.200 is not used by R1, now it is used by R2. Then all the packets will be sent to R2. Okay. Now again, let me tell you. So now suppose, consider that this router has come back. The router has come back, R1 has come back, or the link issue has been solved. Now actually, okay, I mean, then you will think that this router will go back to standby and this will go back to active, but it will not. It will not go back. Okay, if at all you want to go back to the previous state, if at all you want to make R1 as the active router again, you need to enable something called preemption. You need to enable the feature called preemption. Preemption means getting back to the old state. Okay, so if the preemption is enabled, then only this will go back to the old state. That means R1 will become the active and R2 will become the standby. Then if it's R1 is the active, then he'll start using the IP, virtual IP 10.0.0.200. Okay, then all the packets will be sent to R1. Clear? Any doubts? Okay. Now, so this is how it works. Now let me just tell you one more thing. Okay, that is sufficient. Again, you're going to study it in the CCNP level, so this much is sufficient. Okay, you got some priority values and all, maybe in NP you will study it. Okay, as this is the theory portion, I'm not going to explain it again. Okay, I mean, I'm not going to explain further. Okay, now, so this is the Hsrp, hot standby redundancy protocol. Okay, now we'll come to traditional versus SDN. Traditional versus SDN. So you can write the heading traditional versus SDN. Okay, so now let me tell you about that. So far you have been studying the traditional networking. Traditional networking. So in traditional networking, let me tell you, so you will have multiple routers. Say suppose you got R1, R2 and R3. R1, R2, R3. Suppose you are connecting into serial 0/0, serial 1/0, serial 0/1/0, serial 0/2/0, like that you are connected. Okay, and here the bandwidth is 1.544 Mbps. Here also the bandwidth is 1.544 Mbps. And here R1 is connected to a network 10.0.0.0 and R3 is connected to a network 20.0.0.0, suppose. Okay. Now, in traditional networking, each router, so this is R1, R2, R2 and R3. So each router has got 3 planes here. Each router has got 3 planes or 3 area. So let me tell you, the first one is got 3 planes. So the first one is called data plane. Data plane. The second is called control plane. And the third one is called management plane. Data plane, control plane and management plane. The same is applicable here. Data plane, control plane, management plane. Again the same thing. Data plane, control plane, management plane. Okay, now let me tell you about the management plane. Management plane, say it does the function, or the function of this one is to like manage the SSH connection or the say VTP connections or the VTY, not the VTP, VTY connections and all. Okay, how to manage the routers. Okay, now the control plane functions, or the control plane has the functions of OSPF, Hsrp, like that. Okay, or if at all it's a switch, then it's a spanning tree, those things and all. Okay, that means say if at all, so you run the OSPF, all the OSPF related things will come in the control plane. I might have taught you about the OSPF, sending the OSPF hello package, and then receiving the OSPF hello package, then sending the DBDs, sending LSR, sending LSU. Those things are, so here the control plane will be responsible for those things. Getting it? So now if the OSPF works, then R1 will have 20 dot network in its routing table. Only if he has the 20 dot network in his routing table, he'll be able to send the user defined packets. It means if you send something or if you ping something, those are the user defined packets, right? So sending the user defined packets, suppose receiving it via this interface, say moving it to from layer 2, say they'll de-encapsulate it and they'll check the routing table, then they'll re-encapsulate it and send through the interface. Those things, it is data plane is responsible for those things. Getting it? So data plane is responsible for data related things or the user defined frames. Okay, so or the user defined packets. So the control plane functioning is a must for the data plane functioning. Getting it? So this is the traditional networking, and in the traditional networking you will have to go to each and every router and do the configurations. Now we have come up with something called SDN. We have come up with something called SDN, software defined network. Software defined networking. Software defined networking. In SDN or software defined networking, let me tell you. So here we got the routers R1, R2, R3, and we got the networks connected to these routers. Now here the R1, suppose the R1 router. R1 router will be having control plane here. So he'll have, so in each router they'll have control plane. So this is the R1 router. So now suppose this is the R2 router. This is the R2 router. Okay, and this is the R3. And again there's a small mistake here. It's not the control plane, guys, it's the data plane that they're having. Is the data plane. So all the devices will have individual or their own data plane. Their own data plane. Now they will not have the individual control plane, but the control plane will be centralized. It's a centralized control plane. Centralized control plane, which is called controller. It is called controller. It will be there in a server. It will be there in a server. It will be there in a different machine. Getting it? So you will have a control plane or a controller or centralized controller which is located in a different machine. And the control plane needs to interact with the data plane. The control plane needs to interact with the data plane. And that interaction is called SBI, southbound interface. That's called SBI, southbound interface. Okay. Now, this control plane needs to be accessed. It needs to be accessed. I know it is boring, so let me wind it up faster. Okay, so the control plane can be accessed by using certain applications. It can be accessed by using certain applications. The applications will be developed by some developers. Okay, so the application will be developed and the interaction between the application and the control plane is called NBI, northbound interface. It's called NBI or northbound interface. Getting it? So let me again tell you. So the data plane here, they'll have some programs, and the control plane also will have certain programs, and they will communicate with each other through something called API, application programming interface. Okay, again the same thing happens here. The application will have certain, say, programs running inside that, and the control plane will also have certain programs running inside that, and they will be communicating with each other through some API. Clear? Now the application and the control plane can reside in a single machine, can be in a single server, or it can reside in different machine. Clear? And again, so the application here, for application to work, so they need to access the control plane. So they will send certain messages to control plane. So for application, suppose you got certain application or software or something which is developed by the developers. Okay, so for application to work, they need some information from the control plane. So they will send certain messages. These messages are called Crud messages. Crud means create, read, update, delete. These are messages: create message, read message, update message, delete message. These are called Crud messages. Okay, which is similar to some HTTP messages called HTTP verbs. Those are called HTTP verbs. Get message, set message, something like that. Okay, so you will have some Crud messages which is similar to HTTP message or HTTP verbs. Now, if at all they are telling something to read, I want to read something, so give me some values. Okay, so or create some values, right? See, they are gonna send back these values to application. They are gonna send back these values to application, and while sending it, it will be of a specific format. It'll be of a specific format, and the format can be of JSON. You might have heard of JSON, right? JavaScript Object Notification. It can be of XML format, Extensible Markup Language, or it can be YAML format. YAML ain't the markup language or something. Okay, so these are the formats in which they will send the information or they'll send the values to application. Getting it? Okay. Now coming, so within maybe just 5 minutes we'll wind up, no worries. So the application, so this is the SDN structure, software defined networking. So this is the application, and with that application you are accessing all the network devices. Or what you do really is, Okay, so you will access or you will do the things in the application. You will insert the values or you will define something in the application, and the application will communicate to the control plane about it, and the control plane will push the data into the, or will push the configs or whatever it is, it will get pushed into the data plane. Clear? And so you don't really have to work in all the devices now. From a single application you can control all these devices, and that is called SDN, software defined networking. Okay, now so software defined networking, so Cisco, and again let me tell you a small history. So the researchers have researched the SDN at various levels. So they have come up with, so they have made an organization called ONF, Open Networking Foundation, where they have researched based on the SDN, and they have come up with certain models. I suppose it's OpenStack or Open something, Open SDN or something. They have come up with a model called Open SDN. Then based on that, Cisco also developed certain things. Cisco also started researching the SDN at various levels. So Cisco started researching the SDN at the data center level. They started researching the SDN at data center level. They started researching the SDN at campus level. They started researching the SDN at WAN level. Okay, and in the WAN level they have developed something called SD-WAN. It's called SD-WAN. That means they are in the WAN side. If you implement this SDN, then that is called SD-WAN. So Cisco's SD-WAN, you might have heard of it. Okay, then if you implement something, say the SD-WAN or the SDN features when implemented in the campus, it is called SD access. It's called SD access, software defined access. Then if it is, say, when they have researched in the data center, they named it something called ACI, application centric infrastructure or something. Okay, so again the intention here is to make you aware of these terms. That's it. Okay, so ACI here is the SDN, Cisco's SDN at data center level. Now say SDA means is the Cisco's SDN feature in campus level. Now SD-WAN means it is the Cisco's SDN feature implemented in the WAN level. Getting it? Okay, so better you can go and feeling sleepy? Sure? Okay. Now, if at all you you are not feeling sleepy, then well and good. I thought your eyes were going down. Okay. Now, yes, Deva is very active, right? Okay. Now almost done. Okay. Now, again, these things will use the controller. They'll have their own controller. They'll have their own SBI. They'll have their own NBI and all. Okay. Now, so for the campus network, you have a controller called DNAC. You have a controller called DNAC, and it's called DNA Center. It's called DNA Center, Digital Network Architecture Center. It's the controller which is used in SD access. Clear? Okay. Now, the next thing. Okay, you can write it down. Is the controller in SDA in campus network. Okay. Now the final thing, with SDN you can go with automation. You can implement automation. Okay, you can implement automation using some automation tools. Like Puppet, Chef, Ansible, etc. Puppet, Chef, Ansible, etc. So again, the automation tools you can say you got some models called imperative model and declarative model and all. Okay, don't want to go into those things. Okay, so just understand these are the automation tools: Puppet, Chef, and Ansible. Clear? So these configure, so the automation things and those programs, those things and all you will do it in CCNP level. Clear? And again, you got more things in the say, and let me tell you one more thing here. Okay, in SD access, the last thing in the SD access, when you go with the SD access, you got three things. Okay, underlay, overlay, and fabric. Underlay, overlay, and fabric. So underlay, it is the physical connectivity. It is the physical connectivity. And overlay means forming the tunnels with those devices and all. And the environment which consists of underlay and overlay is called the fabric. Bas, this is enough. Don't want to make it bored again. Okay, so this is the SDN. Okay, traditional versus SDN and all. Okay. Yes. So shall I wind up?
Yes.
Okay. No energy. Okay. So then we'll wind up. So let me just stop recording.